Hello, EGR343 students. I just making this video to help you to understand how we represent the relative movements, and also I will continue to explain about how we describe the motion using not only coordinate system, rectangular coordinate system, but we also use normal tangent or polar coordinate system as well. So I hope you get some help from this video. Yeah, let me start with the relative motions. So when we describe the motion, we just use first a reference, right? So let's say this is like a particle, and particle just move along this curved path. Then how we describe motion? We first set the reference, right? So let's say we have the reference here. This is my x, this is my y, and then once you set the reference, each coordinate has a unit vector. So this is unit vector I pointing to the x-axis, and unit vector of j pointing to the y-axis. So after that, if you make a position vector for your object, so this is my position vector. Let's say this is A. Then you can easily get the position vector for A object. So R, let's say this is position vector. Right? So RA with respect to O. So we just make our origin as O. Then this indicates the position vector of A with respect to O. Okay? So this is certain x component of scalar and I, and also certain y scalar components and j. So basically, if you just measure from here, and this one would be x at this point, okay? Then this one would be y. So let me make this one is a little bit longer. So this is y coordinate, and this is y and x that represent the position of A at this given moment. Okay, then let's expand our ideas a little bit. So maybe let's add one more object. So we have another object here, for example, and then that object is moved along a different curved path. So let's say this one is moving along this curved path. So let's say this is B. Okay. So we can also make the position vector. So this is my position vector. So my position vector R, B, with respect to O, is a certain x and certain y. But right now, since we add another object, when you represent the scalar component of each position, in order to differentiate between those two, I will put some subscript here, xa, ya, and this one is xb, I, yb, j. Okay? So in a case, this x of A is xa, and y of A is ya, and likewise x of B here is xb. And let's make this our x-axis, or a little bit more extended. Okay, this is my x, and then this is yb, right? So this is my position vector R, B, O. This is R, A, O. Then if you want to get the velocity, if you want to get the velocity of A object or B object, you can just take time derivatives of your position vector and position vector of B. Okay, at this time, what if we want to get the velocity of A not with respect to O, but with respect to B? That's the relative velocity, right? Just imagine that you are in or on the object B, and if you just observe the motion of A, that's the relative motions of A with respect to your position. Okay, so it's not from your origin, okay, which is fixed, but your position is also moving as a function of time. But you want to describe the motion of A with respect to your position. That's relative motion, right? So how do you find the relative motion of A with respect to B? It's very simple. It's very simple. Because you just make a vector with respect to your position B. So this is R, A position with respect to, not O, with respect to B, right? That's your position. So what is RAB then? So my relative position RA over B is what? This is a vector summation. This is a vector. So if you look at this triangle that consists of three vectors, RAB is equal to RAO minus RBO, right? So just simple vector equations. Vector summation. So if you add this one and add, if you add this vector and this vector, you will get this vector as a result. So that's why in order to get this one, I subtract the B vector from A. So that's the position, relative position. How about the relative velocity? You just take a time derivatives, right? So I just take a time derivatives of my R, A over B, and dt is dr A over B dt minus. So which means my velocity, relative velocity A over B is equal to the velocity of A minus velocity of B. So it's very simple. So if you measure the velocity of A and B with respect to the origin, then the relative velocity A from A with respect to any position is simply calculated by A velocity minus B velocity. Then acceleration as well. If you take a derivatives of this one, acceleration, relative acceleration is equal to, this is negative minus, that's the relative acceleration. It's very simple concepts. Then let me give you an example here. So it's a very simple example in our lecture. And in this example, let me just erase this part here. So right now we have two plane. Okay, so this is I'm not good at so this is plane A, and we have another plane. So let's say this plane is, this is A and this is B, and this one is going to the right with the velocity of 650 km per hour, and this one is going in this way, and then the angle is 60 degrees, and velocity B is equal to 800 km per hour. Okay? So right now, just imagine that you are in plane A. So let's say you are just right on plane A. And what's the velocity of B with respect to your position? So I want to find my velocity of B with respect to A, right? So this is relative velocity. So this is B with respect to origin. Origin is somewhere here. So this is origin. So you just describe the velocity of A and B, which are 650, 800 with respect to some fixed position, right? But I want to find the relative velocity of B with respect to A. So this is V A over O, okay? So everything is just a vector, okay? So let's say horizontal is X and vertical is Y. Then what is the VBO? Okay? So this is going in this direction. So if you're just thinking about this is my X and Y, okay? So what is the vector of B? So my vector of B is 800 minus, and this is a 60 and this is 60. So if you just, for example, if you, let's say this is X and Y, and this is 60 degree, and which means this is 60. So I know that my velocity of 800 can be broken down onto this X and also this Y. So I want to find a VB X and this is VB Y component. I want to break down my vector onto X and Y, and then this is a negative direction, so minus 800 and cosine 60. So this X component is 800 times cosine 60 I, okay? And also Y direction is negative, so this is 800 sine 60 J. Actually, this is a VBO, okay? And I need to subtract VA with respect to VA is simply 650 I. Right? Okay, so we can just simply solve these vector equations. So this is equal to what? So 800 minus 650. So cosine 60 is 1 over 2. So this is minus 400 minus 650 I and 800 sine 60 J. So that's it. So that's the answer. So this is minus 800 sine 60 J kilometer per hour. So actually this is relative velocity. So if you observe the motion of B with respect to A, then the velocity is like this one. So it is actually, this is 1050 kilometer per hour, and this is negative to 800 sine 60 kilometer per hour. So the velocity you observed is this one. So this is the V over A. That's your velocity, direction, and also magnitude.